Hi, good afternoon. It's James Dumont with MicroCAD. We'll get started in about a minute. I can't see if who all of the attendees right now, so let's leave about a minute or so for people to join, and then we'll get started with the presentation. All right, so we're going to get started. Again, my name is James Dumont. I'm with MicroCAD, and I want to welcome everyone today to our webinar that's based on the Product Design and Manufacturing Collection. Unfortunately, there's not enough time to really demonstrate live, so this presentation will mostly be PowerPoint slides with some videos to actually illustrate some of the more powerful subjects we want to cover. But if you see anything that's interesting to you, please reach out to MicroCAD, and we would be happy to set a time up so we can go over more detail in any specific topic that might be of interest. So today, we're very excited to speak with you about the Product Design and Manufacturing Collection. We're frequently asked about the collection and what does it have to offer and how can users benefit from it. So today, we're going to look at the collection, its top tools, and see how we can take product designs from excellent to exceptional. So we are here to talk more than just designing great products. We're talking about your entire product development process using a collection of integrated applications. The Product Design and Manufacturing Collection, it includes the tools that you need to develop your ideas, simulate them to make sure they work, analyze the dimension tolerances, create CAM toolpath strategies, and factory layout for optimizing throughput. And all of the data for every tool you use is stored and managed in one secure project. It's those capabilities that enable you to be more innovative. With that, you'll be able to win more bids, streamline your manufacturing, and you'll be able to improve your overall product performance. We are going to show you some of the reasons why and how we can accomplish these outcomes with the collection. First, your design work is a foundation for everything. That's why we're starting with Inventor. The general capabilities of Inventor, they are well known by most of you, so I'm going to only cover a few points before we dive into the other products in the collection. What makes Inventor such a great design tool? It enables you as a designer or engineer to focus on your designs, less on how to use each feature in their controls. Because you're going to find specialized modeling tools to speed up your design, things like sheet metal tools that are available to quickly create the features in your model, and you're able to get accurate flat pattern to your laser cutter. There's a frame generator. It models a 3D for you as you specify the skeletal structure and a cross-section of choice for each different type of member, whether it be tubing or channel, things like that. And the tube and pipe for assemblies, it includes routing for rigid pipes, bent tubes, flexible hoses for machining designs, and consumer products. And also, don't forget, there's flexible modeling methods, and they're there to remove any hurdles to quickly model and edit your 3D parts. The parametric editing, direct editing, and the freeform capabilities, and they can all be used interchangeably and all together at once. So let's talk more about design automation tools. When we do talk about automation, we're really focused about talking about iLogic. Approximately 1/3 of everyone with a seat of Inventor uses iLogic regularly. It is a rules-based design engine. It's one of the most powerful and effective ways to save on time. You can define the rules to quickly reconfigure your designs. This helps to satisfy the customization demands of your customers. You can even use it to generate an instant quote. And because you can quote faster and more accurately, you'll be able to get your designs to manufacturing faster. And this is a great tool to win more business. It's also important to understand the scalability of the work you do in Inventor. What happens when you want to make your forms available to people who don't have Inventor? How can customers fill out forms from any location? When you're ready to take the next step in automation, we'll be here to show you the Autodesk Forge Design Automation API for Inventor, and this is where you can experience the advantages of running iLogic in the cloud. Interoperability used to be one of the biggest hurdles for most companies. We're always having trouble translating files. We're asking for customers for multiple file types because we really don't know sometimes which one will work best depending on the model. And you sometimes get a new version of a part, but you don't know exactly what changed. So Inventor AnyCAD, that's a technology that Autodesk has come up with, and it changes all of this for the better. Because you can simply open the file and maintain an associative link to it, if any changes are made, the model just simply updates. For some of you, this is the greatest technology ever, especially if you're like me and you've been doing this for a very, very long time. So sticking with interoperability, let's talk about BIM. For those of you who don't know what BIM is, Autodesk we know is filled of acronyms. It's the Building Information Modeling. It's the foundation of digital transformation in the architecture, engineering, and construction, the AEC industry. So participating in BIM projects is now easier than ever for those of you that are looking to get spec'd into building projects. Or you might be collaborating with architects to design and make custom designs for buildings. Your designs may be highly detailed and you love it, but the architects, they don't need all that detail in their models. In Inventor, they can be quickly simplified using automated tools and then authored as BIM objects. This video is going to walk through an explanation of how Inventor works with BIM. So those of us that create custom fabricated designs for building projects like staircases or awnings, many times we do need the Revit data to work around, and it's always been difficult in the past. But beginning in 2023, data exchanges can now be sent directly from Revit to Autodesk Docs. Using the Forge viewer, users of Inventor can then access the Revit view they need and include it in their project. It remains associative if the Revit user uploads a revised data exchange. So this, of course, eliminates the need to email Revit files and revisions that need to be imported into the Inventor environment. One of the biggest advantages of this is that this information, when you're working with Revit data and Inventor, you treat it just like any other 3D model. You can use constraints to place it where it needs to be, and you can design and do your work around it as native geometry. The last thing I want to mention for Inventor is collaboration. Again, this has always been an issue. You have this great design or an idea, but how are you going to then communicate it to your customers or co-workers for review? The answer to that in Inventor is called shared views. In just a few clicks, you have an online representation of your design that can be opened anywhere on any device, Android, iPhone, iPad, computer, it really doesn't matter. People with access to your design can view it, they can make comments, they can measure the geometry, they can section it, they can explode it, they can even create mockups and redline it if there are any questions or concerns. So I'd like to show you one of the items we talked about in Inventor. Let's take a look at a demonstration of design automation using iLogic. iLogic is a technology. It's included in every seat of Inventor. It enables you to quickly make changes to your products, whether it's to quickly get started on the next project, or you need to configure a bespoke product for your customer. In the example here, you can see a form being used, and it's being used to change the conveyor. And in the form, there are options for text boxes, sliders, pull downs. You can build your form the way that you want. This ensures that the person filling it out doesn't create something that you don't make on the shop floor. The interface for building rules is meant to be intuitive, so anyone who uses Inventor can use it. It does not require advanced programming skills. Just build your rules right in the iLogic interface. Then, as an option, create a custom form that anyone can use with access to Inventor. You can see it in action, even see the changes happen in the drawing environment. You can set up boundaries that are invalid for the manufacturing floor or in the field. You may have parts or subassembly that have unlimited configurations. You can configure them as you're bringing them into your assemblies. Not only use forms to create new models, you can use them to fill out the title blocks in the drawings. This will greatly decrease the busy work that it takes away from your design. So once again, we can use pull downs, selection boxes. It all speeds up the process. Everyone wants to automate the processes. iLogic is the obvious investment in time for companies looking to reduce repetitive tasks. This is just a customer story. It's FS Elliott. They're an example of a company that has discovered the power of using iLogic to automate the 3D modeling of their most complex products, impellers. You can see the impeller in the image. It's a very difficult type of geometry to create. With iLogic and automation, they decrease the amount of time to model these impellers from days down to 15 minutes. So now let's talk about some of the integrated tools for Inventor that are part of the product design and manufacturing collection. Now, everyone wants their assemblies to fit perfectly, but at what cost? Most of you know the impact your manufacturing tolerances have on machining cost. Or is it the tolerance stack up preventing your assemblies from fitting or functioning properly? Autodesk Inventor Tolerance Analysis is designed to help you make well-informed decisions while specifying manufacturing tolerances. I'll show you what this looks like in a few minutes. So you've already designed a great product, but what does it look like to transition to manufacturing? Some of you can benefit from the factory layout tools that are in AutoCAD and Inventor to help optimize equipment placement and production. So basically, it makes your seat of AutoCAD even better at factory layout. And with a click of a button, you can see the whole thing in 3D inside Inventor and Navisworks. Let's take a look at advanced simulation. Most 3D CAD software today has some entry-level FEA. Many of you use it, which is great, but every license of Inventor Professional, for example, comes with stress and frequency study types. But are you getting all the information for how your design will behave in the field? Autodesk Inventor Nastran offers a complete set of simulation studies. Nonlinear, thermal, fatigue, and dynamic studies are all included. They all offer a complete understanding of your product performance with accurate results. Autodesk Inventor CAM. It provides a seamless workflow from design to manufacturing because it also is integrated in Inventor. It includes functionality from 2.5 to 5 axis machining, as well as lathe and mill turn applications. When you have multiple flat components that come in different shapes and sizes, it definitely can be a challenge to create a nested layout that produces a minimal amount of material waste. Autodesk Inventor Nastran is an integrated nesting software that helps you optimize yield from raw material. So, nesting studies can be created and then updated to reflect any changes to your design. You can easily compare nesting studies to optimize efficiency and use Inventor CAM for the laser cut toolpaths. So let's take a look at what tolerance analysis does. Simply put, it really just enables you to make trade-offs between manufacturing and assembly tolerances to reduce cost. And of course, it ensures that your assembly components are going to fit. And if you've ever had to do this manually with a spreadsheet, you know it's time consuming, it's not easy, and it's very much prone to error. The best part of tolerance analysis is that it's built directly into the Inventor user interface. Each stack-up analysis captures the relationships defined in the assembly model. It can then calculate the cumulative effects of geometric dimensions and tolerances included in the stack-up. So it reads the tolerance values that you have already specified when you hopefully have applied 3D annotation to your model. This helps you to create a model-based definition that also can include GD and T. Tolerance values can then be evaluated and edited directly in the tolerance analysis panel. Any updates automatically stay in sync with your existing 3D annotation and GD and T. Tolerance analysis helps you understand how contributing tolerances impact each stack-up that you're analyzing. Calculations, they can be viewed as worst case, RSS, and statistical. So if you're already doing 3D annotation and GD and T, why not leverage all of the existing information with tolerance analysis? These tools allow you to save time in manufacturing by machining to a lower but acceptable tolerance, reduce cost on over-tolerance components, and ensure proper fit and finish during the final assembly. So this time, I want to take a look at Inventor Nastran. This also is a fully integrated application inside of Inventor. So this is where you can gain a full understanding of how your design is going to perform in the field. This example is a frame. They're going to apply a static load to see if this is over-designed or under-designed. Many situations, many companies that don't do analysis will typically over-design to make sure the product will work, it will last, it'll function, but there's a cost associated with that. So with the Inventor Nastran, we're able to do several different analyses, and we can determine the best appropriate size and structure of this assembly. So not just performing linear static studies, we can also test designs for vibration to make sure that it's not going to shake itself to death. We can check for low and high cycle fatigues. How many loads can it actually take before cracks begin to form? We're going to run a thermal heat study transfer and apply those temperatures to a thermal stress study. We can run a nonlinear study. These are incredibly powerful and accurate. They're accurate because there are material models included for all types of designs. In this example, they realized that the structure is way over designed, so they're going to analyze it with a smaller structural member for the legs. And they're looking at the safety factor, and at that, they still satisfy the design requirements, and they're well over the safety factor minimum value. So this is going to be saving money, saving assembly, saving labor, and be confident that the design will last. So far we focused on integrated capabilities that designers can utilize within the Inventor environment. But within the product design and manufacturing collection, there are other tools that do extend what you can achieve while working directly with Inventor designs. Let's take a look at some of the additional options. So with engineering workflows becoming increasingly more complex and cross-disciplined, there is a need to coordinate and reuse model data in wider parts in the organization. So within the collection, Autodesk offers applications that cover a much wider spectrum. This helps you to maintain your 2D information, enabling model coordination and other disciplines such as architecture, as well as providing tools that can be used to produce high-quality imagery and animations. So although 3D design applications have been available for many, many years, most companies still rely heavily on 2D. And that's because in many instances, the delivery of a project still often requires a combination of both 2D and 3D design. Similar to office-based tools, or especially Adobe products, we recognize it's all about using the right tool for the job. So Continuing to use AutoCAD for specific use cases is still a requirement for many of you. One of the benefits of working with AutoCAD and Inventor is that users can take advantage of the associativity that they both provide. You can reference 2D AutoCAD drawings inside Inventor. This assists in creating 3D models faster. The Inventor drawing environment saves as DWG, and the view information generated from the 3D world can be associatively played back into the AutoCAD environment if the need arises. This offers a truly flexible workflow, which enables both environments to remain associative with each other. As mentioned a moment ago, many of us work in a multidiscipline environment. One of the challenges that we often face is coordinating and communicating designs for review. Although many CAD systems can import information from other sources, it is often difficult to manage change. And depending on the complexity of the information, it may become challenging, especially when you have a model that contains hundreds of thousands or even million plus components. This is where Navisworks comes in. This application is not only built for design review and walkthroughs, but it can also be used for clash management of models imported from other CAD systems. So in addition to non-CAD data such as point clouds. So with timelining in Navisworks, equipment information can be synced to your project management software. This will help assist the installation process of your designs. So again, all of this can be accomplished while the data remains associative to the model data. We know that collaboration between mechanical and electrical teams can be challenging, but what if electrical and mechanical designs could talk with each other? That's why the electromechanical workflow between AutoCAD and Inventor was developed. Schematic diagrams can be created within the 2D toolset, AutoCAD Electrical. Inventor Electromechanical ensures both parties are aware of what's happening in each other's designs. So not only are you able to share up-to-date information between your electrical schematics and your Inventor 3D models, but it also gives the appropriate clearances, it also gives the mechanical designer the ability to generate 3D cable routes. If space is tight, approximate clearances can be accommodated and accurate bills of materials can be generated. Virtual prototyping has been something manufacturers have been undertaking for many, many years. Visualizations are often required to sell the concept before any manufacturing takes place. Or, for the mass customized products, taking photos of every possible variation, it just isn't practical. When 3D designs are generated, sometimes capturing a screenshot is really all you need. But what if you need something more professional? Perhaps you need more realistic imagery for a brochure or a website, or you just need to present a unique customer experience that relies on augmented or even virtual reality. Because of this, you need a software application that is dedicated to visual effects for photorealistic renderings and videos. That's why 3ds Max is included as part of the collection. So let's take a look at some of the capabilities of Recap Pro. If you're undertaking projects such as brownfield installations, you need to ensure any new equipment or design is going to fit properly. Scanned data can be viewed within Recap just like any other 3D design. You can measure, filter, and place annotations. These point clouds can then be inserted into your into your Inventor assembly, enabling an understanding of how the new and the existing will work together. One of the core capabilities of Navisworks is the ability to collect all of this data together in a single environment. That includes your 2D layout, different 3D disciplines, and point cloud data. You can then set up and run clash detections between all of the geometry and generate reports of the findings and view that with the additional stakeholders. All of this is to ensure a smooth project delivery and installation. Next, an example of how a customer is taking advantage of 3ds Max. Whether you realize it or not, as part of the product design and manufacturing collection, you have access to produce cinematic quality renderings and animations. It will provide a better understanding of how a design is going to operate and deliver a competitive separation in your market. So we talked about some of the tools within the collection that extended how designs created within Inventor are consumed. Next, I want to talk about the tools that are available when you send your Inventor designs over to the Fusion 360 platform. Fusion 360 is Autodesk cloud-based 3D modeling, CAD, CAM, and PCB software platform, which is all included as part of the collection. What we're going to cover next is how you can utilize this platform to extend the value of data generated within the Inventor environment. First, with Fusion 360, let's talk about generative design. Many of you may have heard of it and understand that it works by generating a model that satisfies a set of design criteria. It's not just optimizing an existing part, but it's something that can generate hundreds of design ideas, enabling engineers to explore significantly more options and much less time than it would take to model a few manually. The study setup not only accommodates material selections, safety factors, and potential cost, but will even produce options based on the available manufacturing that you have available. Once the engineer selects what fits their needs, the finished model can be further edited to accommodate. These are CAD-ready models. So as you can see here in this slide at the top, General Motors designed a seatbelt bracket. By using generative design, the bracket was 40% lighter, 20% stronger, but in addition to that, it was able to consolidate an assembly of 8 parts into one. So it makes it simpler and faster to install. The second method is a company called MJK Performance, whereby the team there were able to develop concepts faster. For them, traditional 2.5 axis was the actual best cost-effective route for them. They were able to save money, safety factor, and they were able to make sure everything was up to spec. So when it comes to making a component, depending on the requirement, you may want to utilize subtractive manufacturing or other times additive. It really all depends. Fusion 360, fortunately, it supports both. Benefits of additive within Fusion: you can take advantage of some of the more organic creation tools to develop a very quick prototype. When you want to generate the physical print, not only the printer templates, but you also have the ability to optimize the printing process itself, such as support structures, fill definitions, orientation, and packing options. And although not specific to an additive, there are advanced capabilities within the product design extension, such as lattice creation and design guidance, that all aid in decisions when developing parts. Moving on to subtractive manufacturing, which many of us are aware of, have been around. It's actually been a bit long-term focus of Fusion. Not only can you take advantage of the manufacturing environment to generate toolpaths in order to mill or churn your parts, but there are now more comprehensive strategies and capabilities that support organizations' more complex machining requirements. In addition to machining, more recent developments also include the ability to support the definition of on-machine verification and inspection processes. If using Inventor models, there is still the advantage of being able to consume model data associatively. Users can appreciate any change in design, whether Inventor or Fusion-based. So far we've looked at how Fusion can automate design with generative and how it can help drive additive and subtractive processes. But there are tools that extend design collaboration into other parts of a product team. Within Fusion, there is also the ability to generate electronic designs. From the initial schematic to the PCB layout, with layered definitions to create the 3D board representation, this can all be created within Fusion 360. Autodesk also just launched signal integrity for Fusion 360 electronics. This will test for electromagnetic compatibility and interference within your PCB design. This extends what users can develop with Inventor by enabling a bidirectional flow of information. For example, a space envelope or overall enclosure can be sent from Inventor to Fusion, enabling the design of the PCB to occur in the context of a 3D mechanical assembly. Once complete, this information can be linked back to Inventor if necessary. Place it in the PCB design and the enclosure. And the last topic I wanted to talk about was Inventor and Fusion 360 for simulation. All of the previous workspaces can consume model data from Inventor, or obviously anything that was natively generated within the Fusion environment. Although Inventor has simulation capabilities, it may be that you want to take advantage of additional areas such as event simulation or cooling analysis, enabling the ability to simulate heat transfer of chips within an enclosure. The main thing to note is, if users have been given access, they can now seamlessly send their Inventor data into Fusion. This enables you to either offload a job to the cloud or take advantage of tools that may be applicable to a specific workflow. Ultimately, as per all other examples, this highlights how you can extend what is possible using the capabilities within the product design and manufacturing collection. So we're nearly at the end of today's session. Thank you for hanging in there. We did go a little over. The purpose of this presentation was to provide a high-level overview of the capabilities. This page will list a few more links if you find the need to access any more information on any of the topics in this presentation. For those of you considering your options and how you can access these tools, there are now even more flexible ways you can subscribe to the products, from pay-as-you-go to yearly or multi-year offerings. If you'd like to speak to someone for more information, please reach out to someone at MicroCAD and we can assist you with any of your inquiries. For any of the Q&A, I'll check the presentation today to see if there's any questions, and I'll respond with them as best I can. I want to thank everyone very much for their time and energy, and I appreciate for hanging in there, and I look forward to our next time together.